Hello, everyone, and welcome to the Biodesign Challenge of 2020. While a different method of delivery than usual, my team is proud to be here from the University of Wisconsin-Stout. Our team consists of 5 members: Andrew Hurl, Courtney Johnson, Whitney Phillips, Brittany Zavala, and Caitlin Zenz. Especially now, the world is painfully aware that no matter where we live, work, or play, human beings are exposed to an abundance of toxins from our water, air, and other life forms in our biome. Many of these toxins can insidiously accrue and reveal their damage over time, allowing effects to possibly become untreatable and irreversible. What our team wanted to accomplish was a system that empowers our populations with a reliable, low-cost biosensor to proactively rather than reactively monitor our health. In order to accomplish that, we had 3 goals for our biosensor: induce sweat, quickly detect metabolites of toxins within sweat, and display a warning if the concentration of metabolites exceeds a certain threshold. Here in the Midwest, many people reside or vacation in woodsy areas, home to many various forms of toxins, including ticks. Specific tick bites can lead to serious bacterial infection called Lyme disease, the effects of which can be prevented but remain untreated for too long for many in the United States, which can result in chronic symptoms of the disease. This means that tweezers don't always come to the rescue, with test results only being 29 to 40% accurate within the first 3 weeks of exposure. The Center for Disease Control states that every year, some 30,000 people in the United States are diagnosed with Lyme disease. These are only the cases that the state health departments report back to the CDC. Therefore, it is predicted that the number could be more like 300,000. Immediate symptoms can include fever, fatigue, and rashes, but if left untreated, can result in facial palsy, arthritis, and inflammation of the brain and spinal cord within the first 6 months of exposure. Lead poisoning as well begins with symptoms of headache, nausea, and fatigue, but can lead to slow growth, learning disability, and memory loss if left untreated over time. Being a compound commonly found in older homes in the United States, children under 6 are especially vulnerable. While lead-based paint used in homes, children's toys, and household furniture has been banned in the United States since 1978, the paint still resides on walls and woodwork. Lead pipes, brass plumbing fixtures, and copper pipes soldered with lead can also release its particles into tap water, leaving fetuses and newborns at risk as well. While kidneys can filter lead from our bodies, it can be too much for them to handle, leading to buildup over time. Overexposure can cause irreversible side effects to not only our bodies, but our cognitive systems as well. As previously mentioned, lead-based paint was banned in the US in 1978, but many countries are still left without legally binding controls over its use. As of 2017, only 1/3 of the world's countries have put restrictions on the paint, leaving many at risk for high exposure. Yet another environmental toxin that is commonly used across the world is pesticides. Each year, 200,000 people from across the globe die from the overexposure of these chemicals. Populations which are most at risk remain the workers of the farms and the ones who grow and disperse our food. According to the USDA, as many as 57% of these workers in the United States consist of migrants from other countries, leaving this population of farmers high on risk and low on power. The most common methods of exposure is through dermal contact, inhalation, or ingestion, meaning that pesticides trapped in clothing fibers can potentially lead to transmission of toxins to family and loved ones at home. Chronic exposure can result in several cancers, brain and nervous system defects, and damage to many of the organs in our bodies. Children, especially who are exposed, experience slower cognitive function and possible learning disabilities. All 3 of these chemicals can take a long time to diagnose, from Lyme disease being incredibly inaccurate, lead taking anywhere from a few days to 1 to 3 months for test results to come back, and pesticides being a widely used product by a large portion of people every single day. Our team would like to propose a cost-effective and widely available biosensor that can detect foreign substances within the body through contact with sweat in order to expedite and democratize the process of early detection. Introducing Kelp, a state-of-the-art bandana that collects sweat and converts it to allow for early detection system for toxic metabolites, and turns it into a visual cue of the wellness of the people within a community by changing colors when foreign substances are detected. Areas of the body with naturally higher outputs of sweat jumpstart the bandana's biosensor. But why did we decide to use sweat for such an important matter when other tests already exist? What we found was that human sweat is made up of 99% water, a variety of metabolites such as immunoglobulins and proteins, as well as cytokine receptors, which are crucial during an immune response. We also found that sweat was already being used to detect many different medical conditions such as heart failure, kidney function, arthritis, and even mental and neurological disorders such as schizophrenia and Parkinson's disease. An advantage that sweat can have over other tests, such as blood and urine tests, is that sweat can be taken over a long period of time, allowing for a much larger test sample. Knowing that there are many current studies and technologies in development for gray tech sweat detectors, we wanted to find a way to blend this with a green tech solution, possibly even allowing us to grow the product. We investigated a variety of small organisms that could potentially be used to create a cloth-like texture, but also something that could emit an electrical current. We decided on the use of two organisms. Kelp, which is a natural material that has already been used to create fabric and clothing, allows minerals and nutrients to travel in and out of the skin. Also being incredibly absorbent, kelp allows our bandana to pick up any sweat the body secretes. We also found that there are various types of bacteria that both conduct and eat electrical currents, which allow us to create a bioelectrode. We combined these two properties that these organisms had and designed two different kinds of materials for our bandana, one that induces sweat and one that eats the foreign metabolites and changes colors. These two materials are then interwoven throughout the cloth to create an ongoing detection system. These strands of genetically modified kelp are able to continue living and working due to the power of the sun and the sweat that the cloth picks up, meaning that no power is needed and the cloth can work for as long as it needs to. The electrical current was essential due to its ability to induce sweat through a process called iontophoresis. This is a process of transdermal drug delivery by use of small voltage gradient on the skin. Molecules are transported across the stratum corneum by electrophoresis and electroosmosis, as well as increasing the permeability of the skin. Kelp can be worn in any style. It can also be placed with children's toys to sleep with overnight or play with in order to continuously collect sweat. The bandana has three different designs that represent and portray each of the toxins that they are responsible for detecting. These bandanas can then be sold together with the product they are being used with, being tied to the canisters of pesticides or bottles of household cleaning supplies, or even to camping gear, allowing those affected by Lyme disease, lead, or pesticide poisoning to proactively monitor their health before and after activities where they might be exposed, get ongoing feedback of what's inside our bodies, and take steps to ensure that action is taken before symptoms occur. Kelp can also be reused simply by washing it with a cleaning solution. This solution removes the sweat and chemicals bound to the biosensor and reverts the cloth back to its original color, allowing those who are continuously exposed to these toxins to monitor not only their own health, but the health of those around them. We believe kelp could be beneficial to society in that it would not only aid in the diagnosis of disease, but key the world into where problems could arise, while causing no harm to the body, environment, or animal health. With growing health concerns, it is important for the world to take care of those in harm's way and assure the safety of those around us. With kelp, the community can unite in solidarity while knowing that there is a problem that must be addressed and make strides to create changes. This concludes the Kelp presentation, with special thanks to Professors Arthur Neelan and Kim Loken, as well as the Biodesign Challenge organizers and judges. We are pleased to now answer any questions.